All right, it's time to look at some free response questions that are some rate problems. Problems that deal with rates. All right, for the AB calculus test here. So let's look at this one. This is from 2017. This is a no calculator question in C, no calculator. So we've got a boiled potato at time t equals 0 is taken from the pot on a stove, left to cool in the kitchen. The internal temperature is 91 degrees at times t equals 0, and the internal temperature of the potato is greater than 27 degrees for all times. So that's great. It's greater than room temperature. That's kind of room temperature there. The internal temperature of the potato at time t can be modeled by this function, h, and we know it's this differential equation. This is the change in h over time. So h of t is measured in Celsius. All right, so h of 0 is 91, we're told. So we want an equation of a line that's tangent to h, all right? So right away we're thinking equation of a line, and so we should be thinking of point slope form. Y minus y1 equals m times x minus x1, or you can use y equals mx plus b. All right, in this case, y equals mx plus b would work just fine because I think, let's see, we're told times 0, right? That's the y-intercept. And so that tells us that b is 91. That's great. So might as well do that, but we need the slope. How do you find the slope of a tangent line? That was our first big question, and that is the derivative. So we know the slope is the derivative of h, the dh dt. Okay? So we're going to take dh dt, we're going to evaluate it at time t equals 0. All right, and so according to our equation there, it's negative 1/4. And then we have h, and this is the h at the time that we're doing, h of 0 in this case. So h of 0 is 91 minus 27. So we know what h of 0 is, and so we'll put a little h of 0 there. Okay, and we can evaluate that hopefully. So 91 minus 27, that is 64. So negative 1/4 times 64 gives us negative 16. So remember, that is the slope that we just found. So you got to find the slope. That's the slope of the tangent line. So y equals negative 16x plus 91. All right, so that's the tangent line. So now we're asked to use that to approximate the internal temperature at t equals 3. Well, we've got some graph here, some function h, all right? And we know that this is starting at 91, right? And it's going down, all right? And it never gets below 27, it says. So it's maybe kind of an asymptote kind of idea, all right? So, but we don't know the function h, so we can't just plug in h, but we can use this. We know that at temperatures close to t equals 0, we get this. Now, let's go ahead and tweak this. We should make this match. Yeah, it's y equals mx plus b, but better yet, h equals negative 16t. That's really what we should have there. All right, so that line there, all right, that will approximate it when we have a temperature of 3. So we're going to use that. All we're doing is we're just plugging in 3, plugging into the tangent line, and we're saying that that should be decent, should give us an idea. So h of 3 is approximately negative 16 times 3 plus 91, and 3 times 16 is 48. This is negative 48 plus 91, and that is from 50 to 90 is 40, so we're talking 43, right? So talking 43. So again, when we're asked to use a tangent to approximate, you're using the equation, we're plugging it into the equation because we're saying the tangent line is close to the actual curve when you're near it. All right, so use the second derivative now to determine whether the answer is an underestimate or an overestimate, okay? Because what's going on here is this. Let's draw a picture. We got two things that could be going on. We know we have 91, and we know it's decreasing. So it could be decreasing like this, or it could be decreasing, if this is 91, could be decreasing like this, okay? So it depends on if it's concave up or concave down. So the idea is this, is that we said there's a tangent line that comes through here. 1, 2, 3, okay? And so we said, well, this is our approximate. So if it's concave up, then we have an underestimate. But maybe our graph looks like this. Let me make that a little different shape, something like that. Okay, and so we have, 3 is somewhere over here. And we found this tangent line that was going like this. And we found our approximate here. So if the actual curve is concave down, then this is an overestimate. If the actual curve is concave up, then this is an underestimate. All right? So we found the point on the tangent line. We didn't find the point on the actual curve. So, all right. So the idea is, let's use that to decide if it's an underestimate or overestimate. Okay, so the second derivative, we just need to take the derivative of the first derivative, which is, we got this guy, the derivative of, I'm just going to distribute that, -1/4 h plus 27/4. Now let me actually change this so we don't make a mistake. Or just write this as h of t plus. All right, so remember that h is a function of t. So when we take the derivative here, we've got a little chain rule. All right, so we have a derivative of this first part is going to be the derivative of the inside, which is just 1, because derivative of t is 1. And we have -1/4 times dh dt. All right, the derivative of h is dh dt. And we actually know the derivative of h. The derivative of h is given to us in the function, in the equation, right? So we have -1/4 times, -1/4 h minus 27. And if we distribute that out, we have 1/16 times h minus 27. Now, we know that h, we were told in the problem that h is always greater than 27. All right, so that's told to us up here. It's always greater than 27, not greater than or equal to, it's just greater than 27. Okay, so since h is greater than 27, that's given to us in the problem, this is going to be positive, right? So 1/16 h minus 27 is going to be greater than 0, which means concave up. So we got h of t is concave up. It's always positive. So going back to that little situation we had here, we know that we started at 91, right? 91 or 97? 91. we started at 91, and we don't know what h looks like, but we know it's concave up. When we found the tangent line on the first part, then we did the approximate when x is 3, or t is 3. And notice the blue dot is below this concave up curve. So that is an underestimate. So part A is an underestimate. That's the key there. All right. It's below. We don't know what the actual curve is, but it's below. Okay. All right. Kind of trailed off on that one. All right. So an alternative model or equation is given to us for an internal temperature of the potato at time t, the function, and it satisfies this differential equation given to us here. G of t is measured in degrees, and g of 0 is 91. Find an expression for g of t. Based on this model, what is the internal temperature of the potato? So here they want an actual function here. Okay, this is a separable differential equations. What we need to do is we need to get the t's over here. We need to take all those g things over there. So to do that, so let's take our dg dt equals negative g minus 27. Let's make that minus to the 2/3. So we need to divide by that expression, multiply both sides by t, or if you want to think of it as cross multiplying, and we're going to end up with negative 1 over g minus 27 to the 2/3 equals dt. Oops, I've got my dg there. So dg, and we're going to multiply the dt. That's going to be by itself. Or maybe a little nicer way to write this. Oops. What happened there? It would be with a negative exponent, so we have g minus 27 to the negative 2/3 equals dt. All right, now we are ready to integrate. So we can integrate both sides. And when we integrate the right side, that's the easiest one. It's an invisible 1 there. And so that becomes t. Integrating the left side here, we need some u substitution. And so u is just this, and du is 1. So in other words, we don't really need it because du is just 1 there. We don't have to rewrite it, but if you want to, you can. And so we have, just to integrate this thing, we need to add 1, and that becomes 1/3 as a power, and g minus 27. And then divide by 1/3, and when you divide by 1/3, it gets kicked out as 3/1 times multiplied by the reciprocal. And don't forget actually that important plus c. Gotta have that there. Doesn't matter which side, gotta have it. All right. So there we have it. And we want a function for g. That's what we need to solve for. So multiply both sides by 3. G minus 27 to the 1/3 equals t over 3. Divided both sides by 3 to move this guy over there. And we're going to have plus c over 3. Got to divide both of them by 3. But c divided by 3 is just another constant. So sometimes we'll put constant 1. And so this would be a different constant. We can do that. And then we got to get rid of 3. So we raise both sides to the 3rd power. And we're going to get something that looks like this. G minus 27 equals that big mess over there. Add 27, we get t over 3 plus a constant. And then add 27. Now we're told that g of 0 is 91, so we want to use that to find out what c actually is. So when t is 0, we're going to get this. G of 0 is going to be 0 plus C2, lost my cube there, cube plus 27. And we know that this is 91, so that would be C2 cubed plus 27, subtract 27 from both sides, okay, and we get 64 equals C2 cubed, that's a cube there. And so now we're going to cube root this thing, and that's going to give us 4. 4 equals C2. All right, so we can get our equation if we plug that back up in here. Okay, our ultimate goal is to get an equation, so we got G of t equals t over 3 plus 4 cubed plus 27. All right. Now I did just notice something here as I was checking it out. This little negative disappeared. -1 was up there. Should have been out here, either inside or outside. Okay, and so we end up with a negative there. And then we multiply it by 3 or divide by 3, that's going to make it a negative. The C2 is going to stay the same because that doesn't change anything. All right, we just got all these negatives here. All right, and negative, and that doesn't change it to when t equals 3. But what it does change is right here, that this will be negative. You either need that negative inside or you could pull it outside. All right, so there's the function. All right, that's called separation of variables. Now, that probably won't be on our AP test this year. You never know, but separation of variables. All right, so that's how we do rate problems of this type. Now, there's other twists, so practice the other ones. Hopefully that gives you something to go off of.